Right, Putala. Today we are going to discuss our 20th paper. In this paper, we will discuss question related to Newton's law. Right, Pute? Let's see the first question. Pute, read the first question. A man enters into a lift at t equals 0. The lift starts to move at t equal 2 seconds. Pute, according to this sentence, you can identify that during the first 2 seconds, this lift was at rest. මෙයා ස්ටේෂනර් ඉඳලා තියෙනවා නේද ළමයි? Man, weight of the man, compression force acting on the lift exerted by the man, reaction force, normal reaction acting on the man. These are the two forces acting on the man. During the first 2 seconds, lift is at rest. ඒ කියන්නේ පුතේ මෙයාගේ first 2 seconds already acceleration 0. By using this data, you can identify the weight of the man. Normal reaction is given, no? 0 to 2 seconds, normal reaction is equal to 600 Newton. Let's see. You can apply F equals ma for the motion of the man, 0 to 2 seconds. Right? There are two forces, normal reaction and mg. R minus mg is equal to acceleration 0. R is equal to mg. Normal reaction is given. During first 2 seconds, normal reaction is 600 Newton, m, acceleration 10. Then you can identify the mass of the man. It is equal to 60 kilogram. Right? Then you can find acceleration during next 2 seconds. Right? Let's see. In the next 2 seconds, normal reaction is 720. Normal reaction is greater than the weight. Weight is 600 Newton. No? Therefore, definitely, this system accelerate upward direction. Let's see the acceleration during t equal 2 seconds to 4 seconds. Acceleration. To find acceleration, you can apply F equals ma for the motion of the man. Normal reaction is R minus mg is equal to ma. Normal reaction is given during 2 to 4 seconds. Normal reaction is 720. Weight අපි හොයාගත්තනේ. It is equal to 600 Newton. 60 into 8. පුතා මෙතන 120 equal 60. Then acceleration is equal to 2 meters 68. Acceleration is equal to 2 meters per square second, right? Then you can identify the motion of the object during next 3 seconds, 4 to 7 seconds. Again, you can observe that normal reaction is equal to 600 Newton. That means during this time interval, 2 to 4 seconds, object accelerate from 0. Velocity start from 0 and accelerate. Next 3 seconds, 4 seconds to 7 seconds, it accelerate with the maximum velocity that acquired during the acceleration. පුතේ මෙතනින් ගත්ත maximum velocity එකකින් මෙයා constant velocity එකකින් 4 to 7 second move වෙනවා. It is a uniform motion, right? Then why? In the 4 to 7 second, normal reaction is equal to mg. Therefore, acceleration is 0. Right, Pute? Then you can identify the motion during the last 2 seconds from t equal 7 seconds to t equal 9 seconds. Now the normal reaction is less than the weight. That means object should be decelerated towards the direction of the motion. There you can apply Newton's second law for the motion of the man towards the upward direction. R minus mg is equal to ma. Normal reaction is 480. This one is 600 mg. Then acceleration is equal to minus 2 meters per square second. Right, Pute? Now we have find the two acceleration. According to these two acceleration, you can identify the motion of the lift. During the first 2 seconds, it is at rest. During the next 2 seconds, 2 to 4 seconds, it accelerate and acquired maximum velocity. Then 7 seconds, it move with constant velocity, acceleration is 0, then decelerate. These two time intervals are same. පුතේ මේ accelerate වෙලා තියෙන මේ time interval දෙක same. And the magnitude of the two acceleration are same. මෙයාගේ acceleration එක 2 meters per square second, deceleration එක -2 meters per square second. එතකොට පුතේ definitely at equal 9 second එයා මොකද වෙන්න ඕන? rest එකට එන්න ඕන. හරිද? Then you can draw a corresponding velocity time graph to identify the displacement. Total displacement එක අපිට හොයාගන්න පුළුවන් නේ පුතේ area under the curve, right? අපි curve එකේ area එක හොයන්න එතන velocity time curve එකක් අදිමු. VT curve එකක්. 0 to 2 second it is at rest, then accelerate. මෙයා තමයි maximum velocity එක මෙයාගේ, then move with constant velocity 4 to 7 second. During the last 2 seconds it decelerate. Right, Pude? Using this velocity time curve, you can identify the displacement, total displacement. Before finding the displacement, you need to identify this maximum velocity. To find this maximum velocity, you can use the gradient of the curve. Gradient is 2, no? Here you can write here, gradient tan alpha is equal to the velocity acceleration. Tan alpha is equal V over T. This one is the maximum velocity. V over time interval is 2 seconds, 2 to 4, no? Acceleration 2 meters per square second. Then you can obtain the maximum velocity. It is equal 4 meters per second. Now you have find the maximum velocity. Now you can identify this area. Sum of the parallel two side. 2 to 9, 7 plus 3, 4 to 7, 3, no? Divide by 2, altitude is 4. 2, then 20 meters. 20 meters, right? Right, answer is the third one. පුතේ මෙතන units change වෙන්න ඕනේ. මේකේ answers තියෙන්නේ centimeters වලින්. ඒවා meters වලින් එන්න ඕන, right? Answer is the third one. Right. Let's see the answer for the next question. Right, Pude, read the second question. A rope of length 5 meter and mass capital M is kept on a frictionless surface and force of 5 Newton is applied to one of its end. What is the tension at 1 meter from this end? You need to find the tension of the string at this point, right, Pude? මේ question එක ටිකක් special යි. මෙයා inextensible string එකක් තමයි. හැබැයි යාට mass එකක් තියෙනවා. Pude, before finding the tension at this point, you need to identify mass of unit length of this rope, right? Mass of unit length of this rope is it is equal to m over 5. Total mass is capital M. Length of the string is 5 meter, no? Therefore, mass of unit length is meter එකක mass එක, it is equal to capital M over 5. Pude, then you can identify mass of these two segments. අපි මේ segment දෙක මේක y මේක x කියලා. Mass of y segment is equal m over 5 into 4. Mass of this x segment is equal m over 5. Right, Pude. Then you can identify the acceleration of this entire rope. You can apply equation for the entire rope to the right side. Force is 5 Newton, total mass capital M, acceleration A. Then you can obtain acceleration, it is equal 5 over capital M. Then to find the tension at this point, you need to break the string at the given point, right? අපි එතනින් string එක දෙකට කඩමු ළමයි. මම ඔයාලට මේක theory class එකේ කියලා දීලා තියෙනවා, right? You can break the string at the given point. අපි එතනින් කඩමු කෑලි දෙකකට. These are the two segments. Mass of this segment is m over 5. This one is 4m over 5. Then This one is the external force 5 Newton acting on the X segment. Then you can identify action and reaction at these two ends. This segment should be exerted a force on the Y segment to accelerate this segment to the right side. No? This one is the force acting on Y segment exerted by the X to accelerate Y segment to the right side. Then this Y segment accelerate to the right side and it will apply equal and opposite reaction on the X segment. Newton's third law නේද? මේක තමයි ඉතින් මේ point එකේ tension එක කියන්නේ. To find this tension you can apply Newton's law එක්ක ඔයාට X segment එකට apply කරන්න පුළුවන් or Y segment. කැමති විදියක්. Just apply the equation for this Y segment. Let's see the answer. F equals ma to the right side for the Y segment. Mass of the Y segment is 4m over 5. Acceleration, entire rope එකේ acceleration එකම තමයි 5 over m. මෙයාට මෙයා cancel වෙනවා, මෙයාට මෙයා cancel වෙනවා. Then force is equal to 4 Newton. ඕන්න ඔයාට පුතේ මෙයාට මේ X segment එකට equations apply කරලත් බලන්න පුළුවන් මේ. You can apply equation for the X segment. You will obtain same answer. There are two forces acting on the X segment. This external force and this tension. 5 minus T is equal, mass of this X segment is capital M over 5. No? Acceleration 5 over M. Same answer neither. T equal 5 minus 1, 4 Newton. Answer is fourth one, 4 Newton. Right, Pute, let's see the answer for the third question. The figure below shows 2 kilogram mass placed on a rough inclined surface. An external force 24 Newton is applied on the block. Acceleration of the block is 2 meters per square second. You need to identify the frictional force. Pute, before finding the frictional force, you need to identify the weight, component of weight parallel to the inclined plane, mg sine 30, weight is 20 Newton, then 20 sine 30, sine 30 is half, no? Then this component is 10 Newton. Then you need to identify direction of the friction. The frictional force is always a resistive force, no? It opposes the motion. When the object is moving in upward direction, this frictional force acts opposite to the direction of motion. Right? That means parallel to the inclined plane to the downward direction. These are the forces acting on the object parallel to the inclined plane. This external force 24 Newton. Component of the weight 10 Newton. Frictional force F friction. To identify this force, you can apply Newton's third law parallel to this inclined plane. F equal ma. 24 minus 10 minus F friction is equal to 2 into acceleration is 2. Then 14 minus F friction is equal to 4. F friction equal 14 minus 4, 10 Newton. Frictional force is 10 Newton. Which one is the answer? Third one is the answer. Right, Pute? Right, Pute. Let's see the answer for the fourth one. Capital A and capital B, each mass of 20 kilogram connected through a light inextensible string, which runs through a smooth pulley as shown here. Capital A stays still on the inclined plane. Today, මෙයාගේ acceleration එක 0 කියලා තියෙනවා. This one is a light inextensible string, inextensible. Therefore, acceleration of capital A should be equal to 0. මෙයා 0 නම් මෙයාත් 0. This string is a inextensible string. එතකොට මෙයා ඇදෙන්නේ නැහැ. මෙයාගේ displacement 0 නම් මෙයාගේ displacement 0 වෙනවා. Therefore, මෙයාත් rest එකේ ඕන ඉන්න. Right? Then you can identify the forces acting on each mass. 200 Newton weight of this block, 200 Newton. Then you can identify the two component of the weight of this capital A mass, parallel to the inclined plane and perpendicular to the inclined plane. 200 sine 30. This angle is 30, no? Therefore, this one is 30. Then 200 cos 30. Then you can identify the normal reaction force acting on capital A, R, and R. Then the tension of this string, this one is a light inextensible string, therefore tension at the two ends are equal. Tension on the pulley, capital T. Tension constant පුතේ throughout the string ඇයි මේක light inextensible string එකක් නිසා. Then you can identify the tension at this end because this object is at rest, no? Therefore, the resultant force acting on the object should be equal to 0. Therefore, the tension should be equal to 200 Newton. මේ දෙන්න equal වෙන්න ඕන නේද ළමයි? එයාගේ acceleration එක 0 කියන්නේ resultant force acting on the object should be equal to 0 නේ. Right. Then you need to identify the direction of friction. Okay, before identifying the direction of friction, you need to identify the direction which this object tries to move in the absence of the frictional force. අපි හිතමු frictional force එක නැත්තම් මේ object එක capital A accelerate වෙන්න try කරන direction එක අපි අඳුර ගන්න ඕනේ. එතකොට අපිට අඳුර ගන්න පුළුවන් direction of friction opposite to that direction. Let's see. අපි හිතමු frictional force එක නැහැ කියලා. This one is 200 Newton. This component 200 sin theta. Sin theta is half, no? Therefore, it is equal to 100 Newton. Now you can identify direction of motion of this object in the absence of frictional force. Frictional force එක නැත්තම් පුතේ මේ object එක inclined plane එකට parallelly upward direction එකට accelerate වෙනවා. Therefore, frictional force එක act කරනකොට it should be act opposite to the direction of motion. එයා downward direction එකට තියෙන්න ඕන. Got the point? Right, let's see. Then you can consider the forces acting on this capital A object parallel to the inclined plane. This tension is 200 Newton. Component of the weight 100 Newton and the friction. Okay, for the equilibrium of this object, these two forces, sum of these forces should be equal to 0. එතකොට upward direction එකට parallel to the inclined plane 200 තියෙනවා. එහෙනම් downward direction එකට 200 තියෙනවා. ඕන this frictional force should be equal to 100. ඒ මොනොන්ද බං 100 plus 100 200 වෙලා මෙයාට cancel වෙන්නේ. Then the acceleration is 0, right? What is the answer? Answer is the second one, 100 Newton down along the parallel, along the plane. Second one. Second one is the answer. Right, Pute? Let's see the answer for the fifth one. Right, Pute? Let's see the answer for the fifth one. Pute, read the question. When the lift moves up with an acceleration of 2 meters per square second. 2 meters per square second to the upward direction. The reading of the spring balance is 7.2 kilograms. 7.2 kilogram means 72 Newton. Pute, before identifying the answer, you need to draw the free force diagram. Weight of this object is, the mass of the object is not given, right? Mass simple m කියලා then the mass is simple mg, tension T. Pute, here you have to consider the tension of this string as the reading of this scale, right? අපිට මේ scale එකේ reading එක කියලා ගන්න වෙන්නේ මේ string එකේ tension එක, right? Then, using this given data, you can identify the weight of this object. Let's see. You can apply Newton's second law for this mass to the upward direction. T minus simple mg is equal to ma. Tension is the reading, no? Therefore, it is equal to 72 minus simple m acceleration, gravitational acceleration 10, no? M into this acceleration is 2 meters per second to the upward direction. Therefore, 72 is equal to 12 m. Then m is equal to 72 divided by 12. It is equal to 6 kilogram. Now we have find the mass. Okay, then you can apply the equation for the second motion. In the second case, this object accelerate. It is a deceleration. Upward deceleration is, you need to find the reading of the scale when the lift moves up with a deceleration of 2 meters per second. Minus 2 meters per second upward direction. Let's see. You can apply Newton's second law for the motion of this object to the upward direction. T minus mg is equal to ma. T, mass you have find 6 kilogram, gravitational acceleration 10, then 6 into, now the acceleration is minus 2 to the upward direction. That's why I apply the equation to the upward direction, right? T minus 60, මෙතන minus 12 වෙනවා පුතේ. Answer is T equal minus 12, may I am hitting plus 60. 48 Newton. 48 Newton mean 4.8 kilogram. When the lift accelerate with an acceleration minus 2 meters per squared second, deceleration 2 meters per squared second, to the upward direction, reading of this scale or tension of this string is 48 Newton or 4.8 kilogram. Got it? Which one is the answer? First one. First one is the answer today. Easy, eh? Right, today. Let's see the answer for the next one. Right, Pute, let's see the answer for the sixth question. The two identical pulleys which in the system P and Q are smooth and light. Smooth and light. The strings connected are light and inextensible. These two strings are light and inextensible. The mass M in the system P is being lifted by the 2m mass. This one is the 2m mass, right? And mass simple m in the system Q by 2mg force. Here, 2mg force is directly applied to the string, right? We have discussed this question in your class, right, Pude? Just see the answer. Let's see the free force diagram. 2mg, mg, tension T. This one is a light inextensible string. Therefore, the tension at the two ends equal. Today, you can observe that 2mg is greater than mg. Therefore, this one will accelerate to the upward direction. This one accelerate to the downward direction when the system is released from rest. For the motion of 2m mass to the downward direction, F equal ma. 2mg minus T is equal to ma. For the motion of simple m mass to the upward direction, F equals ma. The equations apply karane P system ekata thama. T minus mg is equal to ma. You can add these two equations to find the answer. Minus t to plus t cancel. Then the answer is mg minus 2mg plus 2mg minus mg. Then mg is equal to 3 ma. M to m cancel. A is equal to g over 3. Acceleration of this P system is, magnitude of the acceleration is g over 3. May I accelerate g over 3 වලින් downward direction එකට, may I accelerate g over 3 වලින් upward direction එකට. In the second diagram, Pute, you can identify the tension of the string is equal to 2mg. Because directly it is applied to the, this force is applied to the string. Therefore, the tension at this end is 2mg. Therefore, this one is the weight. You can apply Newton's second law for the simple m mass to the upward direction. 2mg minus mg is equal to ma. Mg is equal to ma. M to m cancel. Here the acceleration is equal to g. Right, Pute? ඔයාලා මේක දැක්ක ගමන් කියන්න පුළුවන්. Here you have applied the force directly to the string. No? Therefore, the tension is equal to 2 mg. But here, tension is less than 2 mg. ඇයි ළමයි මෙතන mass එකක් තියෙනවනේ. ඒක නිසා tension එක 2 mg ට වඩා අඩු වෙනවා. Right? Therefore, the acceleration should be less than the acceleration of q. බලමු answer එක පුතේ. Acceleration of p is g over 3a හරි නේද? Acceleration of p is q is equal to q වැරදි. C acceleration of q is twice that in p or p g over 3 ළමයි මෙයා g. B වැරදි, C හරි. A and C are correct. Fourth one is the answer. Right පුතේ? Let's see the answer for the next question. Right, Pude. Let's see the answer for the question number 7. Here you need to find the tension of the string between B and C. Pude, before finding the tension of this string, you need to identify the acceleration. Let's see the free force diagram. Weight 20 Newton, 20 Newton. 20 Newton, then the tension of between B and C, T1, T1. This one is a light inextensible string, therefore the tension at the two ends equal. Then the second string, T2, T2. Forces on the pulley. These tensions are equal. Make a common string tension. The light inextensible string. Then the weight 30 Newton. May segment weight 40 Newton. It is greater than 30. Therefore, the system accelerate downward direction. I put a sum 40. 40 is greater than 30 Newton. Therefore, B and C accelerate to the downward direction and A accelerate to the upward direction when the system release from rest. Right? Then you can apply equation for the motion of B plus C to the downward direction. What are the forces acting on B plus C? 20 plus 20 plus T2 plus T1 minus T1 and minus T2. And then cancel is equal to masses 2 plus 2 into acceleration A. 40 minus T2 is equal to 4A. Then you can apply equation Newton's second law for the motion of capital A to the upward direction. F equals ma. T2 minus 30 is equal to 3 into A. You can add these two equations to find the answer, to find the acceleration. Plus 40 minus 30, 10. Then 7A. Acceleration is equal to 10 over 7. Now we have find the acceleration of B and C. Then you can apply Newton's second law for the C to find the tension T1. Only for C, F equals ma to the downward direction. There are two forces acting on C, weight and this tension T1. 20 minus T1 is equal to 2 into A, acceleration is 10 over 7. Right, Pude? Then the answer is 20 minus 20 over 7 is equal to T1. 7 common denominator ekam Pude. 7 into 2, 140 minus 20 is equal to T1. T1 is equal 120 over 7. Which one is the answer? 120 over 7. Fourth one is the answer. Right, Pude? Answers for the last 4 questions I will discuss in your theory class. Right, Pude? Inang adara kata iwarai.